There is a star near the center of our galaxy that does not move the way stars are supposed to move. It does not drift. It races. At the closest point in its path, it is torn forward at about 2.5% of the speed of light, more than 17 million miles an hour, and then flung back out into the dark, only to fall in and do it again. Something is holding it on that leash, something you cannot see, something with no surface, no light, no glow of its own, and the mass of more than 4 million suns. The star has a name. It is called S2, but the thing it orbits is the reason we are here. It is called Sagittarius, IH, and to understand it, you have to be willing to feel very, very small. Point a telescope toward the constellation Sagittarius, low in the summer sky, and you are looking almost directly at the center of the Milky Way. Not a metaphorical center, the actual gravitational hub around which every star you have ever seen with your naked eye is turning, including the sun. You cannot see the center with your eyes. Between us and it lie roughly 26,000 light-years of space, and worse, thick clouds of gas and dust that swallow visible light completely. For most of human history, the heart of the galaxy was simply a bright smear in the night, a region no one could look into. Whatever was in there, it was sealed behind a curtain. Then astronomers learned to look in wavelengths the dust could not hide: radio, infrared, X-ray. And when they did, they found that all that dust and starlight was orbiting something. A single, compact source of radio waves, sitting almost perfectly still at the dynamical center of the galaxy, while everything else wheeled around it. They called that source Sagittarius. A asterisk is pronounced star, a small joke among physicists because it is the one thing in that crowded region that is not a star at all. And the region is crowded. Near the center, stars are packed millions of times more densely than they are out here in the quiet suburbs of the galaxy where the sun lives. In the space that around us holds a single star, the galactic center holds a swarm. A whole cluster of them orbits Sagittarius H directly, close in, moving fast. And it was those stars, in the end, that gave the monster away. If you could stand on a world near the galactic center, assuming any world could survive there, the night would be unrecognizable. Where our sky holds a few thousand visible stars, that sky would blaze with 100 times as many, packed so densely that true darkness might never fall. Ribbons of gas and dust would coil overhead, glowing from within, and at the center of all that light would hang the one place the eye refuses to settle, a small, starless absence ringed by the fastest-moving stars in the galaxy, where the light bends and does not come back. Its size, when they worked it out, was strange enough. But size, it turns out, is not the frightening part. Let us start with something you can picture, because the numbers alone will slide right off the mind. A black hole has an edge, not a solid one, a boundary in empty space called the event horizon, the distance from the center at which the escape velocity reaches the speed of light. Cross it and nothing gets back out. Not matter, not light, not information. It is less a surface than a threshold, a line past which the universe stops sending you news. For Sagittarius AHP, that boundary lies about 12 million kilometers from the center. That is roughly 17 times the width of our own sun. Try to hold that. If you replace the sun in our sky with Sagittarius A Ace, its event horizon alone would reach out well past the orbit of Mercury. The innermost planet would not orbit the edge of this thing. It would orbit inside it, already lost. Now shrink the whole picture down. Imagine the sun as a single grain of sand resting on your fingertip. On that scale, the event horizon of Sagittarius A would be a dark sphere about the size of a beach ball. And every planet in our solar system would be a speck of dust drifting somewhere in the room around you. And that beach ball is not the object, it is only the door. And all of it sits impossibly far away. 26,000 light-years means the light reaching our telescopes tonight left the galactic center 26,000 years ago, when the last ice age still gripped the planet and no city had ever been built. If you could somehow travel there at the speed of a jet airliner without ever stopping, the journey would outlast the current age of the universe many thousands of times over. We are not seeing the heart of the galaxy as it is. We are reading a message 26,000 years old, and the whole living history of civilization has unfolded in the time its light spent crossing the gap to us. Here is the part that resists the imagination. That 12 million kilometer boundary is not made of anything. It is not a wall of matter you could touch. It is a region of space so warped by concentrated mass that the geometry itself folds inward. All of the actual stuff, the 4 million suns worth of it, is packed into a point far, far smaller deep inside. 4 million times the mass of the sun, compressed until the escape velocity at the edge outruns light. That is what a supermassive black hole is. Not a giant object, but an almost unimaginable amount of gravity with no bottom that we can describe. There is a strange mercy hidden in that size, and it runs against everything intuition expects. With a small black hole, one a few times the mass of the sun, the gravity changes so sharply across a short distance that anything falling in is stretched thin long before it reaches the edge. Physicists have a plain word for it: spaghettification. Your feet pulled harder than your head until you are drawn out into a thread. But Sagittarius A is so large that its event horizon is enormous, and the change in gravity across a human body, right at the edge, would be gentle. In principle, you could cross the boundary of a black hole this size and feel nothing sharp at the moment you pass the point of no return. You would not notice the most important instant of your life. There would be no wall, no flash. Only the quiet fact, from that moment on, that no direction you could ever choose leads back out. And to anyone watching you fall from a safe distance, something even stranger would happen. Near the edge, time itself slows in the warped geometry. Your descent would appear to drag, your light stretching redder and dimmer, your final approach seeming to freeze at the boundary and fade, an image thinning toward black and never quite arriving. You would experience your own fall in an instant. The universe outside would watch it take forever. This is where Sagittarius A becomes quietly unsettling rather than loudly so, because for a monster of its mass, it is astonishingly calm. Some black holes in distant galaxies blaze. As gas spirals into them, it heats through friction to millions of degrees and pours out radiation. Quasars, the brightest sustained objects in the universe, outshining every star in their host galaxy combined. You would expect the black hole at the center of a galaxy full of stars to feed like that. Sagittarius A barely eats. Only a thin trickle of gas reaches it, and most of what falls toward it is flung back out before it ever crosses the edge. On the scale of its appetite, our black hole is dormant, sipping where a quasar gorges. We even watched it turn down a meal. In 2014, a clump of gas known as G2 swung in toward Sagittarius H on a close pass. Astronomers expected the black hole to tear the cloud apart and briefly flare as it fed. Instead, G2 stretched, rounded the turn, and largely survived. The monster barely stirred. It was a rare chance to watch the thing eat, and it mostly declined. Calm, though, is not the same as silent. Even sipping, Sagittarius A flickers. Every day or so, telescopes catch. It brightens sharply in X-rays and infrared for minutes at a time. Sudden flares as small knots of superheated gas are wound up and shredded just outside the edge before they vanish over it. The monster does not roar, but it mutters almost constantly in a language of radiation we have only recently built the instruments to hear. That is the good news. It is also not a promise. Black holes do not stay quiet forever. Feed one a larger cloud, a wandering star, and it can wake. The heart of our galaxy is sleeping. It has not always slept, and it will not always sleep. Come back now to the star we opened with, the one racing at 2.5% of the speed of light. We can finally say what is happening to S2. It is not being pushed. It is falling endlessly along a long stretched loop toward the invisible mass of Sagittarius A and whipping around the far turn of that loop before it can be swallowed. What looked like violence is just gravity, the same force that holds you to your chair, turned up until a sun-sized star moves like a stone in a sling. And the sling is fast. S2 completes one full orbit around the black hole in about 16 years. 16 years, less than a single human lifetime, to circle an object with the mass of 4 million suns, on a path so wide it would take light itself the better part of a day to cross. Picture the planets again. Mercury, the fastest in our system, takes 88 days to loop the Sun and moves at about 107,000 miles an hour. S2, at its closest approach to Sagittarius A, is moving well over 100 times faster than that. It is the difference between a car on a highway and a beam of light barely holding itself back. And when S2 rounds that closest turn, it does something that would have delighted Einstein. In 2018, as the star swung through the point in its orbit where the black hole's gravity is strongest, astronomers watched its light stretch toward the red, not from motion, but from climbing back out of that deep gravitational well. It was the gravitational redshift, predicted by general relativity a century earlier, measured for the first time beside a supermassive black hole. The star's path even twists slightly with each orbit, exactly as Einstein's equations require. The monster is not only real, it bends light and time precisely on schedule. None of that speed, none of that bending is exaggerated for effect. It is measured. And the way it was measured is its own kind of story. We could not see Sagittarius A directly for most of the time we knew it was there, so astronomers did something patient and clever instead. They watched the stars around it. Beginning in the early 1990s, two teams, one led by Andrea Ghez in the United States, one by Reinhard Genzel in Germany, pointed the largest telescopes on Earth at the galactic center and tracked that swarm of stars night after night, year after year. To do it, they had to fight the atmosphere itself, using a technique called adaptive optics that flexes a mirror hundreds of times a second to cancel the blur of the air. With the Keck telescopes in Hawaii and the Very Large Telescope in Chile, they pulled the galactic center into focus and followed individual stars threading through it. Over 3 decades, they watched those stars trace out full loops in the sky, including S2 completing its entire 16-year orbit before their instruments. A star, seen to round a complete ellipse around a point of empty darkness. Orbits obey strict laws. From the shape of a path and the speed along it, you can weigh the thing at the focus, even if that thing is invisible. And when they did the arithmetic, the answer was forced and unavoidable. Something with about 4 million times the mass of the Sun sat inside a space smaller than our solar system, giving off almost no light. There is only one object physics allows to be that heavy, and that small, and that dark: a supermassive black hole. In 2020, Ghez and Genzel were awarded the Nobel Prize in Physics for that work, for weighing a monster by the dance of the stars cut around it. Then, in May of 2022, we finally saw it. The Event Horizon Telescope, not one dish but a network of radial observatories spread across the planet and linked to act as a single telescope nearly the size of Earth, released the first image of Sagittarius A itself, a ring of light bent around a central darkness. The shadow of the event horizon, 26,000 light-years away, resolved at last. We had heard the monster and the motion of the stars for 30 years. Now we had its portrait, and the darkness in the middle was exactly the size the equations demanded, and the same instruments have caught something close to the edge that is hard to describe without flinching. The gravity instrument at the Very Large Telescope has tracked bright knots of gas circling Sagittarius A just outside its event horizon, completing a full loop in a matter of minutes and moving at roughly a third of the speed of light. Matter, at the last moment before the fall, orbiting so fast that it laps the black hole while you draw a few slow breaths. The final, glowing rim of the drain, seen from 26,000 light-years away. For all we have measured, there is a question at the center of Sagittarius A that no one has fully answered. How did it get there at all? A black hole grows by feeding, and feeding takes time. Yet when astronomers look toward the edge of the observable universe, which is the same as looking billions of years into the past, they find supermassive black holes already fully grown, some of them holding billions of suns, less than 1 billion years after the beginning. They appear too big, too soon, as if the universe had barely started before its monsters were already in place. So where did they come from? One idea is that they began as ordinary black holes, the collapsed cores of the first massive stars, and then grew by swallowing gas and merging with one another over cosmic time. Another is that huge clouds of gas in the early universe collapsed directly into heavy-seed black holes, skipping the star stage entirely and giving the monsters a head start. Sagittarius A, sitting close and quiet, is one of the best chances we have to study a supermassive black hole in detail. And even so, the story of its birth is written in a past we can only partly read. We know almost exactly how it bends light and time today. We are still not sure how it came to be. Sagittarius A has a past, and it has a future, and both are longer than the mind is built to hold. The sun itself is bound to it. Right now, carrying you and every person who has ever lived, the sun is falling around the galactic center at about 500,000 miles an hour, tracing one enormous orbit that takes roughly 230 million years to complete. Astronomers call that span a galactic year. The last time the sun stood where it stands tonight, the first dinosaurs had not yet walked the Earth. It has gone around the black hole only about 20 times in its entire existence. Think about what that means for a human life. Every empire, every language, every person you have ever heard of, the whole of recorded history, fits into a span far too short to register against a single lap of the sun around Sagittarius. H.F. Co. We have never once seen the sky return to where it began. The galaxy turns on a clock so slow that from inside it, the great wheel looks perfectly still, and yet it never stops, and the black hole at its center is the fixed point the whole slow rotation is built around. And the monster's own story is not finished. In roughly 4.5 billion years, the Milky Way will collide with its neighbor, the Andromeda Galaxy, already falling toward us across the dark. The two spirals will pass through each other, tear, and slowly settle into one. And at the center of that wreckage, two supermassive black holes, ours and Andromeda's, larger still, will begin a long spiral toward each other. In time, they will merge, sending a shudder of gravitational waves rolling out across the universe, and leave behind a single greater darkness at the heart of whatever galaxy remains. Far beyond that, in the deep future, the gas runs out, the stars burn down, and a black hole with nothing left to feed on does not vanish. It simply waits, almost perfectly, for spans of time so long they make the current age of the universe look like a single breath. Long after the last star has died, Sagittarius A will still be there, turning slowly in the cold. And here is where you have to let go of the last handrail. Everything so far, S2, the event horizon, the 4 million suns, is the center of one galaxy, our galaxy. The Milky Way holds somewhere between 100 and 400 billion stars, and every one of them, including our sun, is bound to this single dart point. So step back. The sun circles the black hole. The whole spiral of the Milky Way turns around it. And the Milky Way is one galaxy among an estimated 2 trillion in the observable universe. And nearly every large one has a supermassive black hole at its own heart, doing the same thing to its own hundreds of billions of stars. Sagittarius, A'ak, for all of this, is not even a large one. 4 million solar masses is modest as these things go. In other galaxies sit black holes of 1 billion suns, 10 billion and more. One, in a distant galaxy, is thought to hold well over 60 billion suns, a single event horizon wide enough to swallow our entire planetary system many times over and never register the meal. Against monsters like that, the one at the heart of the Milky Way is a small one. It is only a monster to us. Tonight, the sun will set, and the constellation Sagittarius will rise in the south. If you look toward it, you are looking down 26,000 years and straight into the dark heart your whole world is turning around. You will see nothing, just stars and the faint band of the Milky Way, and behind them, the thing that holds them all. We live our entire lives in orbit around a monster we cannot see, that does not know we exist, that will still be turning long after the sun has burned out and the Earth is gone. It asks nothing of us. It simply waits and pulls and keeps the galaxy wheeling in the dark. There is no threat in that. Not to you, not tonight. Sagittarius A is not coming for us. The sun and its planets ride their long orbit at a safe distance and will for as long as the Earth exists. The unease it leaves behind is quieter than fear. It is the vertigo of scale. The slow understanding that the ground under your feet, the planet, the star it circles, and the hundreds of billions of stars beside it are all held in place by a single dark point you will never see, that was already ancient before the first life stirred on Earth. You were born inside its grip. You will live your whole life inside its grip, and it will never once have noticed you were here. Somewhere out there, right now, S2 is beginning to fall inward again.